Alright, let's look at the homework 15.10, problem number 6. Alright, so let's evaluate this double integral using change of variables. Alright, so let's find the Jacobian first. So partial of x comma y with respect to u comma v. Alright, so this is going to be, right, so here's the transformation given here. Alright, so we take the partial of x with respect to u first. So that's going to be 1 over v. And the partial of x with respect to v, you get the negative u over v squared. And the partial of y with respect to u is going to be 0 since it's constant. And the partial of y with respect to v is going to be 1. Right? So this is going to be 1 over v times 1 minus negative u over v squared times 0 is 0. So we're just going to get the 1 over v. Right, then we want to convert these boundaries. So you have a y is equal to 2/3 x. Right, so use the substitution. So y is v is equal to 2/3 times x is u over v. So times u over v. So multiply both sides by v, we get v squared is equal to 2/3 u. So I'm going to just take the square root of both sides. We have v is equal to plus or minus square root of 2/3 u. Right. Similarly, we can rewrite y equals 3x. Right. Then y is v, and 3 times x is u over v. Again, multiply by v to get the v squared is equal to 3u. Then we can just take the square root. We can get v is equal to plus or minus square root of 3u. Alright, so since we're talking about the first quadrant, v is equal to y, so it's going to be only take the positive one. So we only consider the positive square root of 2/3 u, and the positive square root of 3u. Right, the other two is, actually these are kind of nice because xy is equal to 2/3. Right, if you plug in x is u over v and y is v, so this is going to be 2/3, but we can cancel v and v, so you get u equals 2/3. Right, so xy equals 3. Same thing. I'm going to just skip steps because we know that this is going to be u equals 3. Right, so we got that. Alright, so let's sketch the region in UV plane. So here's the u axis here, and here's the v axis there. Right, then let's sketch this. V is equal to square root of 2/3 u. Right, so it's going to be, so it's a square root of 2/3 u, so it's going to probably look kind of like this. Right, and then square root of 3u is going to be a little bit bigger, so I would say it's going to look probably something like that. And so this is, let's say I'm going to just label these. So this is v is equal to square root of 2/3 u. this is v is equal to square root of 3u. Right, and u is going from 2 square root of 3. Right, so that's going to be just a vertical line here, so like something like that. And then u equals 3, so it's going to probably look like that. Right, so this is u equals 2/3, and this is u equals 3. Right, so we're talking about this region like right here. Right, so this is the region. Right, so the integral can be written this way. So you have an integral, right, over this region R, and 7xy dA can be rewritten as, so you have an integral here and an integral here. Right, you have a 7. Right, x is u over v, and y is v. Right, then dA is, remember the Jacobian, so absolute value of Jacobian, but the u is, actually v is positive, so we're just going to get 1 over v. You can put the absolute value, but it really doesn't make any difference. And then we have a dv du, right? So for a fixed u value, say somewhere here, you can see that the v value starts from here and all the way to here. Then, so you know that it's going to start from square root of 2/3 u and up to square root of 3u, right? Then once you've done that, to cover the entire region, you're going to have to start from u equals 2/3, then increase the value of u, then it goes all the way to u equals 3. So we're going to have go from 2/3 here and to 3. All right, so simplify that. So you have v here and v cancel out, so we get that. All right, so let's evaluate here. All right, so I'm going to leave the outside integral. So you have 2/3 to 3. Right, since this is with respect to v inside, 7u is just a constant, so I'm going to put the 7u outside. Then you have a 1 over v, so antiderivative of 1 over v would be natural log of absolute value of v. And this is going from square root of 2/3 u to square root of 3u. Right, and we still have to take the integral with respect to u. I plug it in. If you simplify that, you can see that this is going to be, right, it's a natural log of square root of 3u minus natural log of square root of 2/3 u. Right, so this is going to be using log property, so it's natural log of square root of 3u over 2/3 u. Right, so we can cancel u's, and this is going to be a natural log of, alright, let's see, I'm going to multiply top and bottom by 3, so you have 9 over 2. Alright, so we can probably pull the 1/2 outside, so I'm going to write it as this 1/2, because it's a square root is 1/2 power, place it in front, and then you have a natural log of 9 over 2. Alright, so we just get a number there. Right, so this is going to be, right, combined with 7 and that number, we can just pull that out. So you have a 7 over 2 natural log of 9 over 2, right? So that's just a number. The only thing that's left is u. So antiderivative of u is u squared over 2, simply a power rule. And you're going from 2/3 to 3. All right. So I'm going to just combine this number here and the constant in front. So we're going to have, let's see, 7 over 4, natural log of 9 over 2 times, I plug in 3, so 3 squared is 9, minus 2/3 squared would be 4/9, right? So simplify that. So it's going to be, let's see, 7 over 4, natural log of 9 over 2 times common denominator. So it's 9. So 9 is 81 over 9 minus 4. All right. So let's see, 89 minus 4 would be 77. All right, so we have, all right, so we get, let's see, 7 times 7 is 49, and 7 times 7 is 49, so 539 over 4 times 9 is 36, and natural log of 9 over 2. All right, so let's type it in. All right, so we got 539 over 36 and a natural log of 9 over 2. All right, so let's submit for testing. All right, it came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.